Hello friends, welcome back to another video on this channel. In today's video, I will show you my new creation, an Arduino based tachometer. Now the way it works is basically I have these IR sensors here. These have an IR emitter and an IR receiver on the back. It basically emits out an IR frequency which is bounced off the surface it is kept over, and if it's a light surface or a bright surface rather, it will reflect back most of the frequency, most of the light back, which will be read by the emitter. And if it is over a certain threshold which we set using this potentiometer here, we'll consider that as a light surface, otherwise it will be considered as a dark surface. So as you can see over here, it is currently over nothing, it's not getting anything back, so this LED is turned off. But as I bring my hand closer to it, it is getting more and more reflected, and at some point it starts blinking, like it starts glowing bright green, which determines that yes, it's now getting enough voltage. So I'll just try and show you. So as you can see, when it comes closer it starts glowing, otherwise it's not glowing. Same with this. So I have this 12-volt fan here, just a standard 12-volt PC fan, and I have whitened out one of the blades using just a little bit of white paint. So as you can see over here, when it's over the black surface it's not glowing, but the second it comes over the white surface start glowing again, green. So it can read that it's okay, now it's over a green surface, sorry, over a light surface. So it will then measure the number of times it goes over a white surface in 1 second, and will multiply that by 60 to get the actual RPM and display it over here. So I'll just show it to you working. Over here I'll just use a standard 12-volt lithium polymer battery here. So I'll just connect this. Now this fan is actually quite small, but it actually spins quite fast, even though it doesn't look like it. I'll show you here. So when I put this slightly over it, as you can see, it'll start reading the RPM here. It doesn't look like it, but it is actually rated at around 3000 RPM only, this fan. So there you can see it's measuring roughly, give or take, exactly 3000 RPM. Now the thing is these are not particularly high-end sensors. It's actually quite cheap and inaccurate sensors. These are just for hobby applications. Actually, in fact, these are not even intended for this application. This is actually just intended for like a line following robot, so where you have a white color background and a black color line. So if you want to see that video, I'll leave that linked in the description as well. But anyways, for this particular application, so as you can see, when we move it even slightly, it gets quite inaccurate. So as you can see, now it's just reading 3600 somehow, and now it's reading 900. So just even slight motions will completely mess it up. But as a proof of concept, it just goes to show that if you use a little bit better sensor, this works exactly the same as a professional tachometer. I'll show it to you again. There over white it's green, otherwise it's not. So yeah, it's a quite nice machine. It does do its job, and there's two sensors I told before. The reason there's two sensors is because obviously if I want something set up here, then I'll use this one, otherwise I can use this as a remote sensor. Now there's one more thing about measuring an RPM which a tachometer also has, a real tachometer, and that is the number of blades of your spinning device. So for example, this fan here, I have only one whitened out blade, so it'll read only one interrupt in one revolution. So it's giving the exact accurate RPM right away. However, let's say you have a white color fan. Let's say this fan was white and I had put it on a black color background, and let's say for example this fan had 3 separate blades. So what would have happened then is that every one revolution this fan makes, it will be 3 interrupts because of the 3 separate white blades. So in that case, then it will actually read thrice the number of RPM. So let's say it's a 1000 RPM fan, but it will actually read 3000 because it's in 3 interrupts each second. So in order to change that, we are going to divide the number of RPM by the number of blades the fan has. So in order to change that, we have this button here. Now I was just touching this, so it got quite messed up, but there you can see after resetting it using this button, it's working now. So I'll use this button here to change the number of blades. So it was at 1 because obviously it had 1 blade. Now I clicked it once and it went to 2 blades. Here is 3 blades, that's 4 blades, that's 5, and it'll cycle back down to 1 again. So you can choose between 1 to 5 blades per and basically you just divide that by that number of blades. Now for the wiring itself, the display is a standard display wiring. The data pins are actually 12, 11, 10, 9, 8, 7, which are used by the display. and then the sensors are on pin 2 and 3. It is very important to keep the sensors connected to pin 2 and 3 only and not change that. You can mess around with the display if you wish, but do not change pins 2 and 3, as it uses interrupts to work, so it will count this as one interrupt. Otherwise you'll have to use delay to ensure that you're not getting more than one read per number of like per time it sees a change here. Otherwise that will end up basically in inaccuracy, so you'll have to use interrupts for this to work. However, that means that you'll have to use certain pins, as these don't, all the pins do not support interrupts. 2 and 3 are the two pins which do support for sure. In my testing even I found that many of the pins give inaccuracies, and in some cases it even just completely keeps this light blinking regardless of what you do. So it's just inaccurate, highly inaccurate. 2 3 works more or less fine for this application, so I'll recommend keeping pin 2 and 3 constant for the sensors, and you can keep whatever you want for the others. I'll leave the full schematic down in the description if you guys want to check that out, along with the code as well. Yeah, and another thing I want to mention is you want to use a potentiometer at the third voltage pin, at the third pin on your display. This is basically to set the contrast. So as you can see over here, when I will turn this potentiometer, if I don't mess it up there, so as you can see, when you turn the potentiometer, you can change the contrast, so you can get it to such that there's no display at all, because the contrast is too low, to a point where you'll see that there will be a perfect contrast where you no background boxes, but the writing is perfectly visible. And if it's too far and the contrast is too much, you'll see that it's basically just completely box, so it's unreadable. So you want to use a potentiometer and keep it exactly where you are seeing the full text without any background boxes. And another thing, one last thing, is this last pin on your display. The last two power pins are for your backlight. Now you want to connect the ground of it, which is at the absolute last pin on your display, using a 220 ohm pull-up resistor like this. So this is a 220 ohm resistor here, and you want to connect the display itself to ground. So you'll connect it to ground pin, the last pin, using this resistor. Yeah, that's basically it for this. I'll just quickly switch over to the computer and show you guys the code now. Okay, so as you can see, I've switched over to the computer now. This is the code running on the Arduino. So as you can see, it's quite a simple code for this project. It's a quite short code as well. So we'll quickly explain the entire thing now. So first of all, only library you need is the Liquid Crystal library. You don't even need to install it. It's a pre-installed library in the Arduino IDE itself. Now this is the pin assignments. So we are using 12, 11, 10, 9, 8, 7, which I just mentioned. 2 and 3 pins are for sensors, so these are interrupt capable pins. If you do wish to change them, I do not really recommend it, but if you do, just ensure that the pin you are using is an interrupt capable pin. Now we are connecting the button onto pin number 5. That basically winds up your entire wiring. Other than that, you don't really need to change anything in this code, but I'll just explain it to you in case you want to use this in something else as well. So this is just initializing the display standard, and this is just your standard interrupts and like integers and all the definitions here. We are initially saying RPM is 0, and this volatile int, this is basically just your counting. So we are counting how many interrupts in 1 second we are getting, and this is the number of blades. So this is what we are changing using that button. And this is just for checking the time itself. So 1 second. Down here we are just beginning the LCD, starting serial. We are setting all the pins as inputs. And this is important. You are attaching the interrupt to sensor 1 pin as a object 1. So we are counting the number of object 1s, and it is falling means basically like the interrupt here. So it will actually set it to low. Like normally it is high when it is white, but it is black is low. So we are changing it to that when it reads white color, it will basically increase the count, if that made sense. So that's why we are interrupting falling. Otherwise, if it was opposite, so it's active high basically yours, then you want to change this to rising instead of falling. So just check your particular sensor's datasheet. If it says active high, change this to rising. Otherwise, leave it as falling. This is just setting the LCD and giving 2-second delay to set everything up. And this is LCD clear, so it's just clearing the LCD. Now here is the important part. So you are getting the current time, and here we are setting up the previous. Basically, we are getting the time when we are setting it up, and each each run of the, like, basically we are currently trying to get the amount of time which has passed, and we are subtracting the current time from the last time we checked, and if it is greater than 1000, then we will say that okay, 1 second has passed. So we'll now set the previous time to the current time, so as to reset the count again. Now again, here is what I was talking about. So we'll multiply the count, object 1 here is the count, we'll multiply that by 60 because we are getting RPM, because we are measuring per second here, so we are actually getting RPS value, rotations per second, and we'll divide that by the number of blades here. It says multiply here, but this should be divide, so this is actually a mistake on my side. Divide by the number of blades. There, fixed. I will divide it by the number of blades. Here is objects, so this is just the integer we are resetting after each resets, after each second, so we don't accidentally start accounting it and it will tend to then go to infinity, which we don't obviously want. And this is a void function to print it to the LCD itself. Now here is the button press part which I was saying. So obviously we are connecting the button to ground, and then we are input pulling, we are setting pin 5 as input pull up. So basically every time it's pressed, it will connect the pin 5 to ground. So then we can read that, and each time we are saying we'll cycle it through 1 to 5 number of blades. We'll set a 250 millisecond delay, and then we'll just print the currently selected number of blades. This is the print to LCD, so we are printing RPM 1 and then printing the actual value of RPM 1, and same with RPM 2, and same with the number of blades. We're just printing the number of blades, giving a 1 second delay here, and we'll continue. And these are just the count functions, so we are adding 1 to each of these objects per number of count when it's called over here. So when we'll count it here, let's say there's an interrupt, we'll count this, which will then set up this void function. We'll add 1 to the number of current objects, and then it will be read by this here, over here, this part of the code, which will then multiply it by 60 and divide it by the number of blades, and then send it to the LCD, which will print it. So that's basically it for this. I hope you guys enjoyed this video. If you did, please be sure to leave a like, subscribe to the channel, and yeah, I'll see you guys next time.